Hello, and welcome back to the Validity Podcast. I'm your host, Valentina Rodriguez, and today's episode 10. Every time I do a new episode, it's still just wild to me that we're already at 10 episodes, and also that we're making our way through basically the entire course content for the Science of Physique Enhancement class that I took last semester. Well, I didn't take it. I helped facilitate it, but I obviously still sat in on the classes and took notes so that I could share everything with you guys. So as we talked last episode, it was fat loss supplements part 1, and today is fat loss supplements part 2, and we're going to be talking all about caffeine and L-carnitine. So in this lecture, in the class, it was actually only given on caffeine, but I did give a physiology of fat loss lecture to Dr. Campbell's undergrad class, and I did a deep dive on L-carnitine research because I personally take L-carnitine every single morning. It's in ALPHAMINE, which is a thermogenic pre-workout that I take every single morning before I cardio. I sip it while I journal, and then once I'm done journaling, I head out to cardio. So naturally, I want to make sure that everything I'm doing has some kind of science-based evidence to support why I would take something. So I included that in the lecture. So we're going to be going through some of the research that I found on the L-carnitine front as well. But before we get into the science, as always, some updates when it comes to Dr. Campbell's lab that I am the research coordinator for. The world's first reverse dieting intervention study, we are officially open for recruitment. So if you're interested in undergoing a maintenance phase, followed by a pretty aggressive dieting phase, followed by one of 3 potential post-dieting strategies that you'll be randomly assigned to in order to study which post-dieting strategy is best for mitigating weight regain after a dieting phase, then please email reversedietstudy@gmail.com and we will get back to you with all the forms needed to determine your eligibility and to get you hopefully onboarded in the study. So very, very, very exciting. We've had a very overwhelming response when it comes to people displaying interest in joining the study. So we have been grinding. Landon and I, which is one of the other research coordinators, we have been grinding through this email. The rest of the research team is ready to take on any viable subjects as their clients and get them undergoing the study, which is incredible because this has been months and months and months in the making. And you guys know because I started recording this podcast last semester, literally started recording this in September or October of 2023. And we were already underway to start designing and planning the study. And now it's officially coming to fruition. So unbelievably excited on that front. From a personal front, my prep YouTube series is officially live. I know I talked about being a little bit scared to publish that, but it is published. It is live. And I think I have 2 episodes up right now, another one going up this weekend. I hit a new low this morning. We still don't have my regional show kind of solidified because we're trying to figure out if we want to wait a little bit longer and do one further away or do one closer to me, geographically closer, but it's a little bit sooner. So I'm not going to be quite as competitive, but at the end of the day, I really just want the national qualification at this regional. I'm not going into it with anything else other than just I want a good time with my friends because if it's local, my friends will be there and I want to get the qualification and then I still have plenty of time before the national circuit starts and I don't know which national show exactly we'll do, but we're just kind of trying to see how my body's responding and then decide accordingly what will be the most strategic show to do to achieve my goals this season. So I'm very excited and just grateful that I finally started responding and hitting new lows because I was pretty stuck for a little bit. So I think those are all the updates. I finished my semester. You guys already knew that. Summer classes are underway, and let me tell you, the workload for the summer classes is unbelievably overwhelming. I'm filming this podcast on a Tuesday instead of my usual Fridays because I have been so backed up and busy with the summer workload and the reverse dieting study that's underway. So juggling those 2 things is probably at least double the workload of my normal semester, which is insane because my normal workload is already pretty high. So, yeah, the good thing is that one of my summer classes actually ends next week. So it's 3 weeks of a lot, but it's only 3 weeks. And then I'll just have the one class, which is still a lot. It's actually pretty ridiculous, but whatever. Got to do what you got to do. So if you're a student, if you're just a busy person, if you work multiple jobs, if you have physique goals and a really busy lifestyle, please know that it is so hard. And there's so many times that you're going to doubt whether you can take everything on at the same time. But one of my favorite quotes in the world is, don't complain about having a full plate when what you wanted was to eat. Like, I thrive off being busy. I wanted to be the research coordinator for the world's first reverse dieting study, for the largest study we've ever done at the lab. I wanted to graduate early. I wanted to do summer classes. I wanted to prep. I chose all these things. So as overwhelmed as I am, it's like an exciting, like invigorating kind of overwhelmed, because I have to recognize that like I'm literally getting exactly what I asked for. So there's that. All right. So now let's get into the science. There's a lot of things when it comes to physiological pathways that I'm going to reference from last episode. So if you did not listen to Fat Loss Supplements Part 1, I recommend listening to that first, because we talk about lipolysis and the pathway of breaking down fat before you burn it for energy. And we talked about how yohimbine works at the breakdown level. It works in the lipolysis pathway. But where carnitine actually works, which we'll discuss a little later in the episode, is on the burning side of the pathway. So I'm not going to reiterate the entire pathway. So I do recommend listening to Fat Loss Supplements Part 1 to have a background of lipolysis and just the general pathway through which fat is broken down for energy. But first, we're going to talk about caffeine, and then we'll get into carnitine. So what is caffeine? In case you guys didn't know, it is 1,3,7-trimethylxanthin. It is a naturally occurring alkaloid. It's an organic compound. It comes from plants, and it contains at least one nitrogen, and it has 3 methyl groups. And when we consume caffeine, part of the caffeine metabolism pathway is to demethylate this methylated compound. And when it gets demethylated, it gets converted to one of 3 potential metabolites that then go on to have physiological functions in the body. The most abundant metabolite that comes from caffeine is called paraxanthin. About 84% of the caffeine that you metabolize becomes paraxanthin. And paraxanthin, in a nutshell, breaks down fats and increases blood glycerol. So it mobilizes your fuel stores. Another metabolite that caffeine can be converted to is called theobromine, and about 12% of caffeine gets metabolized into theobromine. And theobromine, in a nutshell, dilates your blood vessels and has a slight diuretic effect. So when you talk about caffeine making you need to pee, or you talk about it drying you out or dehydrating you, that's most likely the theobromine metabolite that's having those actions. The last and least abundant metabolite that comes from caffeine is called theophylline. And this, in a nutshell, dilates your airways and helps with asthma. So it's a bronchodilator, and only about 4% of caffeine becomes theophylline. So it's definitely not like caffeine is being indicated as an asthma medication, but it does have that effect on your airway vasculature to a very, very small effect. So when we're talking about the metabolite that is predominantly responsible for any kind of thermogenic or fat burning properties that caffeine may possess, it's going to be predominantly paraxanthin, and that's the one that helps mobilize your fuel stores for subsequent burning. And when we're thinking about caffeine and what it does in regards to fat loss, in the grand scheme of things, we know that in order to lose fat, we know that in order to lose weight, there's 2 sides of like the energy balance equation. There's the calories that you consume, and there's the calories you burn, and you need to be in a net deficit in order to lose fat. And caffeine actually acts on both sides of the energy balance equation. So caffeine reduces the calories that you consume, and it also increases the calories that you burn, or the energy that you expend. So first, we're going to talk about the first part. When it comes to caffeine and the reduction of energy intake, there is a moderate to small effect seen on appetite suppression from caffeine supplementation. And there's 2 different studies. We're not going to go into each one individually because they're very similar and they were conducted by the same researcher. Both were conducted by Judas et al. In 2013. And both of them essentially gave subjects either a placebo or a caffeine dose that was 5 milligrams per kilogram of body weight. That dose was divided into 2 doses, one in the morning and one after lunch. And they were given this for 4 consecutive days, and they compared it to the placebo. And what they found was that participants on the caffeine supplementation actually lowered their caloric intake by about 5 to 8% compared to placebo. So is this significant? Statistically, yes, it was significant. Practically, 5 to 8% intake reduction is not of a high enough magnitude to where I'm like, oh my God, you're going to notice that you can't even finish your meal because you suddenly started drinking caffeine. No. But does 5 to 8% of a lower caloric intake, without even like thinking about it, it's something that's happening more so physiologically than like consciously, that like very slight appetite suppression over time, can that compound into something slightly more significant? I think so, for sure. And I also think that if it's lowering your energy intake, like I said, physiologically, this isn't like a conscious, like you're white knuckling yourself trying to eat 5 to 8% less than you normally do. No, like it's happening physiologically because of the caffeine acting on different pathways that affect your energy intake. And just having that slight appetite suppression, I think, is an aid if you're in a caloric deficit and your appetite is upregulated. Just in my opinion, if there's no evidence that it's going to hurt you, if there's no evidence that it's going to harm you, and there's evidence that it's going to help you even a little bit, when I'm dieting, I will take any help I can get. So you bet your ass that I personally consume caffeine. I personally probably consume too much caffeine. So let's talk about what that might be. Before we talk about how caffeine affects your energy expenditure, let's look at what the doses should be. So we can have an absolute dose or we can have a relative dose. An absolute dose is if I just say, okay, no matter your height, no matter your size, no matter your weight, you're consuming 200 milligrams of caffeine. So that's a 300-pound person is consuming 200 milligrams of caffeine. A 100-pound person is going to be consuming 200 milligrams of caffeine. That would be an absolute dose. When it comes to a relative dose, which is typically how it's administered in research in a scientific setting and how it should be administered truly in most athletes if you're using it as a thermogenic supplement. I know that like pre-workouts and coffee and all these things just have a standardized amount of caffeine. Like every single person, you know, like the big bodybuilders that take one scoop of pre-workout are getting the same amount of caffeine as me, who's like 109 pounds this morning, taking that same one scoop of pre-workout. We're taking in the same amount of caffeine. So that would be like an absolute dose. The relative dose, which again is what's used in the scientific setting and what should be used like practically, is where you dose it based on body weight. So if you want a 200 milligram relative dose, then that would mean that a 300-pound person is consuming 1.5 milligrams per kg and a 100-pound person is consuming 4.5 milligrams per kg. So it's that same 200 milligram absolute dose. If you're bringing it down to the relative dosing, they have different dosings because the 300-pound person is having a 1.5 milligram per kg dose and the 100-pound person is having a 4.5 milligram per kg dose. So it's very important to consider individual body weights whenever you are dosing, because in the scientific setting, you want to standardize it per milligram per kilogram of body weight. And in general, what's done in the research is around 5 to 10 milligrams per kilogram of body weight. That's typically what we see in the research. And that's what we're going to see in the study that we're going to look at when it comes to how caffeine affects energy expenditure. This was conducted by Dulu et al., published in 1989. So it is one of those kind of landmark studies that really established caffeine as a thermogenic supplement, as a fat loss aid. And the study is titled Normal Caffeine Consumption, Influence on Thermogenesis and Daily Energy Expenditure in Lean and Post-Obese Human Volunteers. So what did they have? There were 11 young, healthy male and female subjects in their early 20s. Half had been lean their entire life, and the other half were formerly obese and had lost weight. So this is what is called post-obese. So they not only looked at how caffeine affects your energy expenditure, but if it had any differences based on your current body composition and your history of body composition, which could speak to potential genetic differences. So this was a very highly controlled study. Remember, if you know past episodes, when we talk about trying to study energy expenditure, the highest quality study you can do is using a room calorimeter, which is where subjects will go into a room that collects all your gases, measures every little calorie that you burn, everything you eat, every calorie you expend is completely controlled. And this is the highest quality, the highest way of measuring changes in any component of your energy expenditure. Because if you remember, when we're talking about your total daily energy expenditure, it's comprised of your RMR, which is your resting metabolic rate. It's comprised of your thermic effect of food, so the amount of calories you burn just digesting food. It's comprised of your exercise energy expenditure, so how much you burn working out, and your non-exercise activity thermogenesis, which is your NEAT, which is the amount of calories you burn doing activity that's not intentional exercise. So fidgeting, walking in the grocery store, taking the stairs. It's not like a dedicated workout, but it's still activity and it's still obviously expending energy. So when we're trying to study any component of your energy expenditure, the highest quality gold standard for that is using a room calorimeter. And that's what they used in this study. So in the study, subjects stayed in a room calorimeter for 24 hours on 2 separate visits. So it was a crossover design. All subjects underwent the caffeine condition and the non-caffeine condition. And the 2 different visits were separated by 7 days. So again, on one of the visits, they were given caffeine. On the other visit, they were not given caffeine. It was blinded. It was placebo controlled. They didn't know what they were getting. And what they did was they stayed in this room calorimeter after an overnight fast, and they logged all the activity that they did, plus the position that they were in, like posture position, to the minute. They logged every little movement to the minute. And when it comes to the caffeine condition, the dose that they were given 6 caffeine tablets. Each tablet was 100 milligrams each, and they were given every 2 hours. So at 9 a.m. with breakfast, then at 11 a.m., then at 1 p.m. with lunch, then at 3 p.m., then at 5 p.m., then at 7 p.m. with dinner. And again, they stayed in this room. Everything they consumed was controlled, 24 hours, everything recorded. And this dosing of 6 tablets of 100 milligrams per tablet equated about 10 milligrams per kilogram of body weight when it comes to relative dosing. So what did they find? In both the lean individuals and the post-obese individual, there was a 5.5% increase in total energy expenditure in the caffeine condition. This translated to about 110 more calories burned in the caffeine condition than in the placebo condition. Is burning 110 extra calories a day significant? It's not astronomical, but in 5 weeks, that could equate to 1 pound of fat, which I would 100% take that. You're telling me that if I have to change nothing except introduce caffeine, and in 5 weeks I'm going to have 1 less pound of body fat? Yes, I'm going to be consuming caffeine in that case. Again, it's not this massive increase. Is it significant? Statistically, yes. Practically, I think just like with the studies that saw that caffeine can reduce the amount of food that you consume by 5 to 8%, they're not huge numbers. But I think they have significance when you think about these things compounding over time. Also, again, when we're talking about being in a caloric deficit and you're working really hard and you're pushing past hunger and you're doing your cardio and you're crossing every T and you're dotting every I and you're checking off every single box, dieting is not easy. I would take any little bit of extra help that I can get, even if it's a 5 to 8% reduction in my total intake, even if it's a 5 to 8% suppression of my appetite, even if it's a 5.5% increase in the calories that I burn, I would take that. So that's the end of what we covered when it comes to caffeine for fat loss. And our overall takeaway was it works. It's been proven in the literature to work. Does it work to this insane, crazy, like the moment you take a sip of coffee, you're going to feel the pounds flying off? Abso-fucking-lutely not. But do I think that small changes still matter, especially in a fat loss phase, especially when dieting? Absolutely. So if you don't currently consume caffeine, I'm not trying to like encourage everybody to like start tweaking off but you know, it might be beneficial for you to start implementing 5 to 10 milligrams per kilogram of body weight of caffeine into your day-to-day when you're dieting, at least, to try to get a little bit of an edge and squeeze a little bit more progress out of your dieting phase. That's my hot take. So moving on from caffeine to L-carnitine. This is where the physiology that we discussed in the last episode is really going to come in. And I'll do a super quick recap. We talked about how when we burn fat, it's a 2-part process. First, you need to mobilize or break down the fat stores. So you have adipocytes, which are fat cells. They contain triglycerides. Those triglycerides need to be broken down into fatty acids. Those fatty acids then circulate and are delivered to your working tissues, where then they are oxidized in a process called beta oxidation. And that's where they're eventually burned and converted to ATP, and that's where the energy actually comes from. So that's the final step of actually burning fat for energy. And when we talked about yohimbine, we talked about how it increases lipolysis. So it increases the rate at which you break down those adipocytes and break down those fat stores. But we also talked about that if you are not in a caloric deficit, you can break down fat stores all you want. Those circulating fatty acids will just be re-esterified and restored back into adipocytes and back into fat cells if there is not a need for the energy that the fatty acids contain. And where does that need come from? Being in a caloric deficit. So yohimbine helps break down fat, but you still haven't burned it until you're in a caloric deficit and you oxidize the fatty acids. So that is where carnitine comes in. So L-carnitine works in the oxidation side of the fat burning equation, the second half of it. And in order to overly simplify the overall oxidation pathway, when you have these fatty acids that have been circulating in your bloodstream because they were broken down from triglycerides, they need to enter the working tissue and the working cells, the cells actually in need of the energy. And in order to derive ATP and derive energy from these fatty acids, they need to enter the mitochondria. We all know, I'm cringing even saying this, but the mitochondria is the powerhouse of the cell. And the reason it's the powerhouse of the cell is because a lot of the energy yielding processes take place in the mitochondria. Oxidation of glucose, of fatty acids, takes place in the mitochondria. So in order for those fatty acids to be oxidized, they have to enter the mitochondria. And there's an entire process that occurs in order to be able to import fatty acids into the mitochondria. And if you don't know, your mitochondria has two membranes. It has an outer membrane and it has an inner membrane. And fatty acids have to cross both membranes in order to get into the matrix of the mitochondria where the fatty acids can then be burned for energy. So this process by which fatty acids are imported into the mitochondria, it's called fatty acid transport, and it utilizes what is called a carnitine shuttle. And a carnitine shuttle is exactly what it sounds like. It is a shuttle that utilizes carnitine in order to import fatty acids into the mitochondria. So again, I'm going to go very, very overview, but before the fatty acids can cross the first mitochondrial membrane, the outer membrane, they need to be activated by being attached to a CoA group. And when fatty acids get conjugated to a CoA group, they become a molecule called fatty acyl CoA. So fatty acyl CoA gets transported into the mitochondria via the carnitine shuttle. And this carnitine shuttle is a transport system that first takes this fatty acyl CoA and it combines it with carnitine. And there's an enzyme called carnitine palmitoyl transferase 1, CPT1. And CPT1 essentially takes this fatty acyl CoA, it pops the CoA group off, and it pops a carnitine group on. So now you have fatty acyl carnitine. Fatty acyl carnitine can now cross that outer mitochondrial membrane. Fatty acyl carnitine is then shuttled across the second membrane via a enzyme called CAT, or carnitine acylcarnitine translocase. And once fatty acyl carnitine crosses that second mitochondrial membrane, an enzyme called carnitine palmitoyl transferase 2, or CPT2, pops that carnitine group off and pops the CoA group back on. So it is a redundant process in that you finish with exactly what you started with, but it is necessary in order to translocate these fatty acids from the cytosol of the cell into the mitochondrial matrix. So I'm going to recap that once more. You start with a fatty acid that's been conjugated to a CoA group. This enzyme called CPT1 pops the CoA group off and pops a carnitine on. So now you have a fatty acid attached to a carnitine, and it's called fatty acyl carnitine. Fatty acyl carnitine then crosses the outer mitochondrial membrane, and it crosses the inner mitochondrial membrane via a transport protein called CAT. And now that it is on the other side of the second membrane, an enzyme called CPT2 pops that carnitine group off and pops the CoA group back on, leaving you with what you started, which was a fatty acyl CoA, a fatty acid attached to a CoA group, and free carnitine. So What was carnitine's role in this entire process? Carnitine is necessary to attach to this fatty acid in order to import it into the mitochondria. So theoretically, and what I'm about to say is all, again, theoretical, based on the mechanism of action, based on the physiology of this carnitine shuttle. Carnitine is a substrate that aids in the transport of fatty acids into the mitochondria for oxidation, for burning, for energy. So if you are carnitine deficient, which I don't even know if it's a thing, but like, work with me here, hear me out. Let's entertain this hypothetical. If you're carnitine deficient, you can't get fatty acids into your mitochondria. You can't burn fatty acids for energy. You can't burn fat. So carnitine is necessary in order to burn fat for energy. Does having more carnitine upregulate the rate at which you burn fatty acids for energy? I don't know. But at the very least, again, theoretically, at the very least, if you supplement with carnitine and you increase the amount of carnitine that you have available for this carnitine shuttle, then at the very least, if your body is in an oxidative state and it's burning fatty acids for fuel, supplementing with carnitine will ensure that fatty acid transport into the mitochondria is not a limiting factor of your overall fat loss. So at the very least, it's providing something to ensure that your body has everything it needs to burn body fat as efficiently as possible. So let's get into the studies. I looked at 3 different studies, and 2 of them had evidence supporting carnitine supplementation, and 2 of them had some data that indicated that it might not be effective. None of the studies reported harm or reported hurting your fat loss goals, but some were neutral and some were positive. So the ones that supported carnitine supplementation, there was a study by Puyanju et al. Published in 2016, and it reported that subjects who received the carnitine supplementation lost significantly more weight and showed a decrease in their body mass index. So in this specific study, carnitine supplementation did increase weight loss. In another study that we're going to go into more in depth once I'm done with this recap, by Talinezhat et al., published in 2020, it found that L-carnitine supplementation significantly reduced body weight, BMI, and fat mass. Okay? The 2 studies that had some evidence suggesting that maybe it doesn't help that much, there was a study by Broad et al. Published in 2006, and it reported that 2 weeks of L-carnitine supplementation does not affect fat, carbohydrate, and protein contribution to metabolism during prolonged moderate intensity cycling exercise. So in this study, they had prolonged cycling. It was for 2 weeks. They were given L-carnitine supplementation, and they looked at contribution of different fuel sources for energy production. And theoretically, if you're supplementing with L-carnitine, you should be able to utilize more fatty acids for fuel. And this study did not find that that was the case. But again, this doesn't work at the mobilization point of the fat loss equation. It works at the burning and the oxidation part of the fat loss equation. So that might be a reason why. The last study that had some neutral evidence for carnitine supplementation was the same one that I said we're about to get into, the same one by Talinezhat et al. In 2020, which found that although L-carnitine supplementation did reduce body weight, BMI, and fat mass, it did not have any effects on waist circumference or body fat percentage, because both body weight and body fat decreased, so the percentage actually stayed the same. But in my opinion, that's not necessarily like a neutral outcome. It's just suggesting that it might not be burning waist adipose or android adipose specifically, which we know that we can't really spot reduce fat, and that will be another episode in of itself because there is emerging evidence on that front, and I still believe we can't spot reduce fat. But let's get into the specific study since it did have a little bit of confounding outcomes. This was actually a systematic review and meta-analysis that combined 37 randomized controlled clinical trials that utilized L-carnitine supplementation and studied weight loss and body composition. And since it did combine 37 different studies, there were different doses used, and the dose of L-carnitine used in these studies ranged from 250 milligrams per day to 4,000 milligrams per day. But the most commonly used dose was 2,000 milligrams per day of L-carnitine. So if you want a reference point for dosing, 2,000 milligrams a day is what I would personally recommend based on the literature. 19 of the studies used L-carnitine alone. 18 of the studies used L-carnitine in combination with a low-calorie diet or exercise, or a low-calorie diet and exercise together. And 2 of those studies included a weight loss drug. But all of these interventions, so whether it was L-carnitine plus a diet, plus exercise, plus both, plus a weight loss drug, those co-interventions were also included in the control groups. So when we're looking at differences, all of these studies, the only thing that changed between groups was whether L-carnitine supplementation was present or not, and they were all placebo controlled. So what do we find? We find that carnitine does indeed reduce body weight and fat mass. And all of these studies saw reductions in body weight, BMI, and fat mass, but it was most effective, and the decrease in body weight was of highest magnitude in the groups that combined L-carnitine with a diet. So this tells us that as effective as L-carnitine supplementation is, it is obviously always going to be more effective if it's in conjunction with a caloric deficit or with exercise. The other distinction that was made was that it was also more effective in individuals with obesity. So they looked at all the participants across these 37 studies, and they divided them by normal BMI, overweight BMI, or obese BMI. And again, across all groups, across all BMI ranges, L-carnitine supplementation did reduce body weight, fat mass, and BMI, but that reduction was greatest in individuals with obesity. So what do we take away from all of this? Since we have some studies saying like, yes, it's going to help reduce your body weight. Others saying, I don't really think it helps burn fatty acids and therefore doesn't really have an effect on fat loss, or it doesn't affect your waist circumference. We've talked about this before. When you have a body of literature, and a lot of those studies are positive and they support the implementation of a certain supplement, but some of those studies are neutral. They say there was no difference between this and placebo, but none of the studies report adverse effects, side effects, detriments, negative outcomes, any kind of regression from the outcome goal. If there's no negative, there's just neutral and positive, we're still at a net positive of research, of literature, of evidence supporting a certain supplement or phenomenon or whatever you're looking at across the body of literature. In this case, it's carnitine supplementation. And it is my personal opinion that with some positive outcomes, especially from such a comprehensive meta-analysis that was 37 randomized clinical trials, like those are quality studies that are being included. So given the nature of the overall evidence putting us at a net positive, I still support that I'm going to take L-carnitine in my fat loss phases. Honestly, I take it year round because I drink my AlphaMine year round when I journal, because even if I don't have like crazy cardio protocols, I'm still going on a walk for steps and I journal every single morning. And that's when I sip my AlphaMine. So it's just honestly part of my morning routine every single day. And I stand by taking it, and I stand by including it in my daily routine, because at the very least, it's not hurting me. And again, just like with the caffeine outcomes where it was pretty trivial and marginal, we're seeing like 5% decreases in intake or 5% increases in energy expenditure. Like, I will take that. Is it huge? No. But I will take any little bit of help I can get. And that's how I feel about carnitine supplementation, and I will always recommend it. It's not something that I would use the way I would use yohimbine, which is where like I save it as a back pocket thing for when I have a client undergoing a pretty aggressive fat loss phase or dieting phase, and it's time to like add in a supplement to really up-regulate fat loss. That's when I would use yohimbine. Carnitine and caffeine is something that I say, hey, let's throw it in there and let's keep it in there and let's make sure it's a part of your day-to-day to just get a little bit extra out of everything that we're doing. So again, if we're talking about how carnitine supplementation works, tying it back to the pathway we discussed, theoretically, carnitine supplementation is going to increase substrate availability for fatty acid transport into the mitochondria. It's not going to burn the fat for you, but if you are in a fat oxidizing state, it can ensure that fatty acid shuttling is not the limiting factor to fat oxidation. So it's just ensuring your body has everything it needs to burn that fat, and that it's not going to be limited by the rate at which you can import fatty acids into the mitochondria. The last thing I'm going to talk about when it comes to carnitine is just to consider that L-carnitine has different administration types, and different administration types have different bioavailabilities. So when we're talking about that 2,000 milligram per day dose, those were oral doses. And oral L-carnitine has about a 5 to 18% bioavailability. If we're talking about dietary L-carnitine, because it is found in meat and poultry and fish, that has about a 50 to 75% bioavailability, but you're getting it in way smaller quantities when it's present in dietary food. And lastly, you can inject L-carnitine, and injectable L-carnitine has about a 90 to 100% bioavailability. And what this means is when you take it orally, part of the L-carnitine is degraded in the digestive system and in the GI tract, and only about 5 to 18% of it actually makes it to your bloodstream. And with injectable L-carnitine, you obviously bypass the entire digestive system, you bypass the entire GI tract, and you get it straight to the bloodstream. So that's why the bioavailability is much higher in L-carnitine. And I'm not suggesting that everyone goes off and injects L-carnitine, because all the studies that we looked at did use oral L-carnitine, and the 2,000 milligram per day dose, like whatever was bioavailable from that, even if you only got 5 to 18% of that 2,000 milligrams dose, that was still adequate and effective at inducing those weight loss, fat loss, and BMI loss outcomes that we saw across the studies. So with that, the overall verdict on carnitine supplementation, just to recap, the research isn't definitive, but it doesn't seem to hurt fat loss outcomes. So it should be implemented because some of the research does support that it helps fat loss outcomes. It does matter what administration type you choose based on the dosing and the bioavailability, but oral is fine so long as you get an adequate dose, and 2,000 milligrams per day should be adequate. And the biggest caveat is that you still need to be in a caloric deficit. A deficit is still required because the overall net fatty acid oxidation is only going to result in fat loss when energy is in demand. You're only going to need to oxidize those fatty acids for fuel when your body needs the fuel, when your body needs the energy. And you need to be in a state of energy demand, which is a caloric deficit. So with that, that's how carnitine supplementation works, and that's why I take it. I mean, this research isn't why I drink caffeine and coffee and pre-workout an excessive amount every single day, but it does make me feel better about drinking the amount of the amount of 1,3,7-trimethylxanthin. Is that what it was that I consume daily? And yeah, so overall, fat loss supplements, part 1 and part 2, I am going to give, if this matters to you at all, this might not matter to absolutely anybody, but the validity stamp of approval is given to yohimbine, caffeine, and carnitine for now. Obviously, science, ever-evolving field. As new research emerges, we can discuss it. We can talk about it. My stamp of approval goes to yohimbine, caffeine, and carnitine. So that's the end of this episode. Friendly reminder, if you are interested in joining the world's first reverse dieting study as a part of Dr. Campbell's Performance and Physique Enhancement Lab, where you'll undergo a maintenance phase, a pretty aggressive dieting phase, and then be randomized to one of 3 post-dieting approaches with the hopes of mitigating weight regain after your diet, then please email reversedietstudy@gmail.com so we can get back to you to determine your eligibility and hopefully get you onboarded into the study. This is very, very, very exciting. This is going to be a landmark study in the world of reverse dieting, in the world of dieting in general, honestly, because we don't currently have any research as to what to do after a diet. So that is the biggest question that we're trying to answer with the study. And it's going to be years in the making by the time it's published, but it will be so, so worth it. And I think it's going to have a really, really profound impact. So I'm very excited to get to lead it. I'm very excited to be a part of it. I'm very lucky with our research team, our research group, the other research leaders, Dr. Campbell. Everybody is so incredible. And I'm just very excited to get to work and interact with all the potential subjects. So obviously, reach out. All the information is going to be linked in the description below. As always, if you have any questions for me personally, you can DM me at thevaliditypodcast, at VallFitt, my personal, my podcast, Instagram, all of that goes. If you want more info on my prep series is live on my YouTube, and I try to yap more about that there. So I'm going to wrap up this episode. I hope you guys enjoyed it, and I will see you in the next one.